Hey, Vlad here, dependencies.com, and welcome to another video. In the previous video, we talked about higher order functions, specifically about functions that take other functions as arguments, but not about the functions that produce other functions as their result. Today, we're still not going to talk about functions that produce other functions as their result. Instead, we're going to concentrate on the benefits that higher order functions provide. Today we're talking about one of the most important techniques in a software engineer's toolbox, the inversion of control, also known as dependency inversion or the dependency inversion principle. And as a byproduct, we're also going to talk about dependency injection. By the way, the only reason why this video is not part of the main Scala playlist is because the content in here is suitable for a broader audience. Now, inverting the flow of control has lots of benefits, and here's the major one. It allows multiple teams to work on the same projects at the same time without stepping on each other's feet, by separating the project into lots of smaller ones and minimizing the dependencies between them. If done correctly, inversion of control will lead to faster compilation and therefore to a more rapid feedback loop, which is something that developers love. Alright, enough talking. Let's do this. As always, we're inside the virtual machine, and we have Ubuntu running inside of it, and we have Sublime on the left, and we have SBT that runs our code. Remember in the video 6 and 7 about subroutines and recursion, we talked about how subroutines take control of your code and then only return it back to the place where they were called once they're done doing what they were supposed to do. Well, today we're taking this principle to a whole new level. The example that we have today is very minimal. We're only going to have two functions, function A and function B. So function B is just going to take a string and return a string, okay? And what function A will do is it will print out B of some string, okay? And as of right now, let's just return message, okay? So all that our code will do is it will just run A. I'm not sure if you can see this already as a beginner, but A clearly depends on B. So let's replace the string with something like this. Hello B, and I want to use raw strings here so that I can do this. Hello B, my name is A, and I depend on you. Okay, let's make it a sentence like this. All right, so we have hello B, my name is A, and I depend on you. So all that B is doing is basically just decorating the message somehow. So as of right now, it doesn't do anything. So let's put something fancy in there. So let's do console.cyan plus message plus console.reset. So what we're using here are the so-called ANSI escape codes, and once inserted in the terminal will interpret them and change its behavior. So and there is a hidden code that is inserted here, and then everything after it is going to become cyan. And if we don't include the reset, then even the hyphen is going to become cyan. Actually, let's demonstrate that. So if we don't have that, then I'm not sure if you can see this, but the second line of hyphens is also cyan now. Let's actually change it to yellow. Maybe it's going to be more visible. So see the second dot line is also yellow. All right, so let's change it back to cyan. Somehow I prefer it, and let's revert that. And this is what we had before we started. One more thing before we continue, because the whole function returns a unit, we can actually put the A over here and it's still going to work. And the reason why I'm doing this is because now it's sort of easier to read. Now I actually never do this in production code, but in this case for educational purposes it kind of makes more sense. So we have main depends on code, which means main calls code, right? Code depends on A, which means it calls A. A depends on B, which means it calls B. So we can sort of read it from top to bottom, okay? Now, the dependency of A on B is a source code dependency, which means if the source code of B changes, so let's say, for example, yellow, then the behavior of A changes. So the source code of A sort of changes. Now, in this example, you can't really see it, but by the end of the video, you will. And by the end of the video, we're going to learn. So right now, what we have is that the source code goes one way and the flow of control goes the same way. And by the end of this video, you're going to learn how to invert the flow of control, right? So that the source code goes one way and the control goes the other way. And here's why it's important. Now, because A calls B and not the other way around, it means that A is somehow on a higher level, right? So it's a higher level policy and B is a lower level policy. So we have two new words in our vocabulary. We have high level policy and a lower level policy. You can think about it in such a way that A knows more about the business. So A contains the business logic and B contains an implementation detail, right? So what is A doing? A is printing out. So first of all, A is producing the string, right? And then it prints out something, right? And what B is doing is just decorating it. So if we change the way how the string is being decorated, then A shouldn't really change. At least the source code shouldn't really change. In fact, you see it sort of see it right now, right? So no matter what I do here, I don't actually touch the letters in here. So I don't actually touch the source code, but somehow A is changing. At least in theory, the business logic should not depend on a lower level implementation detail. So what we're going to do now is we're going to engineer the shit out of it and make it look as if it's a gigantic software project so that you can see how important it is to invert the flow of control. So we have two different responsibilities. There is A and there is B. A produces a string and prints out something. B decorates the string. So let's pretend like we're a company and we assign A to team A and we assign B to team B. So what we're going to do now is we're just going to create team A, which is going to be just an object, okay? And actually it's kind of fun. Let's call it A team. It's kind of cool. Okay, so we have A team, right? And all we're going to do is we're just going to take the A and we're going to move it down, okay? And let's do this. And we're going to have the second team, B team, and we're going to take the B and we're going to move it down like this. All right, so B is fine and dandy. A does not compile because we need to call B team.b, and our main is also struggling because it needs to do A team.a. All right, so now we have pretty much exactly the same code, but now it looks like the whole thing is bigger. And the next thing that we're going to do is we're going to put these in separate files. So let's do this. So as of right now, we just have the main. Let's create a file called ateam.scala, right? And just cut this out, save it, and put it over here like that. And we're going to do the same thing with B, new file, bteam.scala, and let's take the B and put it over here, right? Save here, save there. All right, so we have our main. It just calls ateam.a. Ateam is in a different file, bteam is in a different file, okay? The next thing that we're going to do is we're actually going to separate this into different projects, right? Because we have two teams now that work on this and they can't work on the same project. I mean, technically they can, but in our example, they want to be independent of each other, okay? So the first thing that we're going to do is we're going to go to our build file and we're going to set the organization. The way we do this is by typing organization. And if you're new to SBT, you need to know that you at least need to have empty lines here, right? Empty lines, very important. Okay, so you're going to see in a second why we need to set the organization. And also, this is semantic versioning. And if you don't know what semantic versioning is, just go to semver.org, which is a type of versioning that is used in our industry, which is sort of like a standard, okay? But for education purposes, we're just going to set the version to 1, and this is going to be really important in a second. So what we're going to do now is we're going to leave this whole project alone. We're going to open the file explorer. We're going to go to my folder where I have it, and what I'm going to do is I'm just going to copy that directory 3 times, okay? 3 times, and this one is going to be our main. This one is going to be A team. And this one is going to be B team. So what we're going to do now is I'm going to detach this window and I'm going to put it into a different workspace, just so that you understand that we're not touching the other project. Okay. So what we're going to do now is I'm going to just open every project in Sublime. Okay. So I'm going to open it with Sublime, and this is the main one. So I'm going to put it over here, and we're going to open A team with Sublime, and I'm going to put it over there. Sorry, that's not what I wanted. I wanted to put this one over there, and we're going to open B team also with Sublime Text, and somehow it knew that it should go there. All right, so now I'm going to close this folder. The first thing that we're going to do is we're going to go to the B team, okay? And we're going to remove everything that is not B team. So we're going to remove this file, and we're going to remove the main as well, right? So everything that is left is just the B team, and it has its own build file. Sorry, that's what I wanted, B team and its own build file, okay? And for the A team, we're going to do a similar thing. And we're going to go in here. We're going to remove everything that is not A team. Delete file. So now we have A with its own build file, okay? And over here, same thing. This is the main. So we're going to remove everything that is not main. So we're going to delete this file, and we're going to delete this file. So now we have only main, and we have its own, and main has its own build file. Okay, now in the first workspace, let me go back there for a real second. We had Sublime on the left, and we had a terminal on the right. Now on this workspace, we're going to have 3 different projects, and we're going to use Gwake, which is a terminal that just comes down when I press F12. Okay, and I have a program called BioBoo running inside of the terminal, which will allow me to split the terminal into 4 windows if I want to. Actually, it allows me to split it into as many windows as I want to. Okay, so let me press Control L first so that it scrolls everything up, and if I press Shift 2, then it's going to split the screen like this, and if I press Control F2 now, it's going to split this one like this, and if I go up Control F2, it is also split. So in this one, we're going to, actually let's go to this one. So we're in this one over here, so let's go to dev / main, okay? And I'm just going to press Control L, and over here we're going to do a similar thing, dev A team, Control L. Okay, and with this one, I'm going to go to dev B team, Control L, and with this one, I'm just going to stay in the home folder. Okay, so you remember our dependencies, right? So the main sort of depends on A, and A depends on B, and therefore, by the way, main also depends on B. It's a transitive dependency. Okay, so what we want to do, the first step is we want to see if we can compile something, and because B is at the bottom of the chain, we can probably compile B. So let's try this. Okay, so let's start SPT. Let's also do a clean just for fun. Okay, and let's try to compile it. All right, and it seems to compile. All right, it compiled. Let's try the same thing with the A team. SPT, the same thing, clean, compile. Right, so this should not work, right? Because A has a clear dependency on B. So what it says is not found value B team. And the way we tell SBT how to find B is as follows. We go to A, we go to the build.sbt, and we add another line. We add a library dependency. Library dependencies plus equals. It's the first time that we're using plus equals. It's basically getting added to other library dependencies. And we use dev inside you over here. Dev inside you, and this is why we specified the organization, and you're going to see in a second a bit more why we need it. And then we have the percent symbol 2 times, and if you depend on a Scala dependency, you need to use 2 of them. If you depend on a Java dependency, then you use only 1. And then the name of the project, and the name of the project is B team. Okay, that's the name of the project by default, is the name of the folder. So we're looking for the name of this folder, B team. Okay, and the version of B is 1. All right, so now if we reload, we need to reload every time, or we need to kill SPT and start it again every time we change the build file. Okay, so we're going to reload, and I did a mistake because this needs to be a string as well, the version. All right, so we can just press R to retry. Okay, so now I reload it, so now we can do clean again, and we're going to try to compile. So now what is going to happen is that SPT won't even be able to build it. So we didn't even get to the point where we try to compile things, right? SPT just says, hey, unresolved dependencies. Dev inside you, B team, with a Scala version of 2.12, version 1 was not found. So what SPT is trying to do is trying to find the jar, which is called bteam_212 somewhere online. In fact, it has a list of places where it searches online, and then if it can't find them, there's this one last place where it will look, and it's on your local machine. So we're going to go to our bottom window over here, and in our home folder, so right now we're in our home folder, and by the way, this works in Windows exactly the same way. If you have SBT installed, in your home folder you will have a folder called IV2. All right, and if you go in there, you will have a folder called cache and a folder called local in there. So if we go into local, right, nothing is in there right now. I'm going to press Control L so that it scrolls up. So nothing is in there. And the way you put something in there is by going to, in this case, project B, right, and say publish local, right. So when we do publish local, then we go back down. Over here, there's going to be a folder called dev inside you, and it's here because we specified the organization. If we hadn't done that, then the folder would have been called default. Okay, and inside of it, let's just go inside of it and see what's in there. All right, so inside of it is the folder called bteam_212. Okay, so let's go in there, and over there is a folder called 1 because the version is 1. So let's go in there. And over there we have a bunch of folders. We have docs, IVs, jars, POMs, sources. You don't really need to understand what all of this means. We just need to go to jars. And this is what a jar is. So this is the jar that this project needs. And because we added this as a library dependency over here, now SBT will be able to fetch it. Right? So all we need to do is just to say compile now, and it will just refresh everything, and now it will understand that, okay, this jar is over there and this is the one that I need, and then everything will be fine. Now before we continue, I need to mention that there are many ways how to manage dependencies between projects, and I specifically chose the most painful one so that I can drill this into your head that this topic of today is probably one of the most important one for a software engineer, not for a programmer. Watch my video about difference between computer science and programming and software development. As a programmer, it doesn't really matter, but as a software developer, this is one of the most important things. So I chose the most painful way so that you see how painful it can be, because it is also the most realistic one. This is also how projects are usually managed in the wild. Now we're going to play the same game with A and the main, right? So we need to publish A, right? So we publish local. Okay, just so that the main can compile. So we're gonna, in fact, let me do Control KB here and over here so that we can just see more stuff. So I'm just gonna copy that. So I'm gonna go to the build file of the main. Okay, I'm just gonna add this as a library dependency, but in this case we're talking about the A team. This is what we had all along, but just now it's a bit more explicit, right? So the main project has a dependency on A, and A has a dependency on B, and B has no other dependencies. Okay, so now if we go into SBT in main, we can clean and we can run, and we should have the same thing as we had before. There we go. So I hope that at least by now it sort of implicitly became clear to you that if these were actually completely different teams, that if team B is not ready yet, then team A is not ready yet. And if team A is not ready yet, then the whole project is not ready yet. And this is exactly what we're trying to fix here. By the same token, if team B was actually ready, and therefore team A was ready, and therefore the product was ready, and then we would push this into production, and then a month later or something, there would be another version of team B. So team B change this to yellow, for example. In fact, let's try this. We're going to change this to yellow, right? And because it's a different version, we need to increment the version. Okay, and now because we changed the build file, we need to reload, right? And we need to publish local. Okay, and in fact, let me go down here real quick. Right, so you see we have two folders here now, folder 1 and folder 2. Okay, so now if we try to compile team A, it's still going to compile, right? Because it still depends on the version 1. And if we go to main, same thing. If you run again, it still depends on the first version. And this is what I meant in the beginning, that this is a source code dependency, right? So we actually now it's visible that we actually have to go to A and we need to change something, right? We need to change. Even though we're not changing like the source code of the function A, we need to change something in the project A. Okay, so this is what we need to do. We need to go to build tool, I'm sorry, to build.spt of the A team, and we just say, okay, now we have a dependency on the version 2, and because this changes our behavior, we also need to increment our version, right? So now our version is also 2. Okay, so we go back to the A team, we reload, we publish local, and our main still has the same problem, right? So if it runs, it still runs the old version of team A, right? And therefore the old version of team B, the first version, right? So we still need to go over here, right? And say, okay, well, now we're depending on the second version of A team, and because it also changes our behavior, the whole version has changed as well. And only now, if we reload and we run, only now it became yellow. So this is another indication. Look, the versions are always 2, 2, 2, 2, 2, 2. So even though we have multiple teams, they cannot move without stopping each other, right? So they cannot move without each other. They cannot move independently. They cannot change the code independently. They can't do anything independently. Everything has to be aligned. All right, dependency inversion to the rescue. And to be more specifically, high order functions to the rescue, because we're going to use high order functions to invert those dependencies. In order to do that, let's look at team A for a second. So what it's doing is it basically says, hey, I need something that will decorate that string. It doesn't really care who will do that, right? It doesn't really care that it will be team B, right? And this is what we're going to do. We're going to convert the function A into a higher order function, right? So in real life, you can imagine this as this. Let's say we didn't have a software project. Let's say we had an engineering project. We had a company that builds tables, right? And we had one team that builds the top of the table and the other team that builds the legs of the table, right? So they don't work in the same building. They have their own tools. They do things completely differently, right? Even though it's the same company. In fact, it doesn't even have to be the same company, but for simplicity's sake, let's say that it's the same company. So what they do first is they get into the same room, or they get on the phone, and they decide about some common thing, right? Because they decide about the common sort of protocol. They decide about the holes on the top of the table, how wide they should be, how thick the screw should be, so that the lag fits into the table. So they define some common thing, some common protocol. And the common protocol in our case, let's go back to software, is this type. The decoration means string comes in, string comes out. Therefore, if we put another function over here, we put the protocol in here, right? And it's going to be a function that takes a string and produces another string, right? Then all of a sudden, we can just call the protocol, right? And we can just, in good faith, assume that the team B will follow this protocol, okay? So what we have now is, it should compile, right? Unless I made a small mistake. Hold up, let's go up. Compile. Okay, it compiles. But because we changed something, we need to go and we need to change our version, right? And also, by the way, notice that now we don't have the dependency on B, and this is exactly what we wanted, okay? So now we don't have the dependency on B. So I changed the build file, so let's reload. And it still compiles, right? Because B is not mentioned anyway. It's not mentioned in source, right? It's not mentioned, okay? So A does not depend on B anymore, which is amazing, okay? So this is the third version, and let's publish it. So we're going to publish it, and we're going to go to main while it's publishing, and we're going to say, okay, you know what? We're going to depend on A team version 3, and because something changed, we're also incrementing our version to version 3. And by the way, notice that B still stayed on version 2. Okay, so let's do that. Okay, and let's go down, reload. So now we're going to try to compile, but it's not going to work, right? Because we still sort of need B. And now comes the cool thing. Let's say that the team B is not ready yet, right? As soon as we give it some parameter here, right? So we're going to say protocol equals some fake protocol, and fake protocol is going to be a function. It just needs to sort of needs to implement exactly this protocol. It needs to be a function that takes some string, right, and produces some string, right? So even though team B is not finished, we can sort of already start working on something. Right? Let's say, okay, you can't decorate our string, so we're just going to return it as is. Okay, so we're just going to use the fake protocol. Okay, so let's try now. So see, now it works without team B. Now let's say team B is ready now. How do we actually use team B? Well, team A does not depend on team B, but we still need team B, right? The main still needs the team B. So let's do here B team dot B. Let's try if this works. Compile, or actually run right away. It says, okay, I didn't find value B. Well, of course, because before, when main was saying that we have a dependency on team A, and team A had dependency on team B, transitively, automatically, our main had a dependency on team B, but now it doesn't happen. So now what we need to do is we need to specify it explicitly. So the main now actually depends on team A, and it still depends on team B as before, but the version is different. Okay, so reload, and now we run, and now everything should work as before. Now this is interesting, right? So let's say at some point later, team B comes along and says, okay, we're gonna, you know what, we decided that we're gonna decorate that string a little bit differently. So we're not gonna convert it to yellow, but we're also going to capitalize the string. So we're gonna do capitalize, actually not capitalize, let's do everything uppercase, right? To uppercase. So let's see if this compiles. Yeah, so it compiles. So now, because it's a change, we need to change the version as well, right? So we're going to change the version. We're going to reload. We're going to publish local. And notice, team A did not care about this. Okay, team A is still fine. Team A does not have any dependencies whatsoever, right? So now team B has no dependencies, now team A has no dependencies. Only the main project has all the dependencies at the same spot. And this is, by the way, a very common pattern. So so now the main goes and says, okay, you know what? Now we're also going to depend on the third version of B. We're going to reload, and we're going to run. And now it's not only yellow, but it's also capitalized. One more thing that I sort of forgot to mention, because Scala also has functional literals. Remember when we implemented this fake protocol, we actually didn't have to. So we could have used, because it was such a small code, we could have said, okay, you know, for example, let's just reverse or something, right? Something like this. Okay, so functional literals are sort of like a cherry on top of that whole pattern, right? So now if we run, it's actually just gonna reverse it without having us to have an explicit definition and then use add expansion to convert it to a function object. But that's just a sidebar. So let's revert that back to this and run again. So what we gained is inversion of control, right? So our teams can work independently. So the control still goes from here to here to here, but the source code doesn't. It goes from here to here and then it stops, right? It doesn't go further. So let me switch to code real quick, so that you rather see the code instead of the build files. So yeah, we're pretty much done with this video. I'm just going to say a few things. First of all, this whole dependency inversion pattern, as awesome as it might be, it actually comes at a price. There are 3 items on the price list. The first one is that the code is now a little bit harder to understand because the flow of control is literally inverted, right? So this is our first project, right? So in fact, it's sort of hard to see here as well. Let me think real quick. So let me try this. No, this. Okay, let me have a team over here and B team over here. So it's sort of easy to understand this code. Okay, so we have code. Code just calls A just calls B doesn't call anything. Okay, it's sort of very easy to understand. Whereas in our project now, we code calls A, but it passes in another function, right? So then we go to A, and then A calls print line with whatever this function is returning us, right? So we sort of don't even, it's a bit harder to reason about, especially for beginners. And this is a super simple example, and it's already harder. So in a larger project, it's even harder. But the benefits of this, they're still worth it. So this was the first item on the price list, and the second item on the price list is that we need more code. And again, this is a small example, so you don't really see that it's, so right now it's just a little bit more code, but in a bigger project it's actually sort of a lot of boilerplate code. But again, it's worth it. So over here we need to explicitly wire things together, right? And by the way, I sort of forgot to mention, so this whole inversion of control is the same as dependency inversion, and dependency injection is happening over here. So in main, dependency injection is where you actually choose which implementation to take. So over here, it's literally injected into A. The dependency on the protocol is injected into A. And number 3, as quite a few other techniques in a software engineer's toolbox, this one also sort of depends on this notion of being able to predict the future, right? So this whole thing works with this one assumption that the protocol, right, the type of the protocol doesn't change, or at least doesn't change too often. This works because this type of a function where a string comes in and a string comes out is already defined in the Scala standard library. So both team A and team B, they depend on the Scala standard library. Right? So once it changes there in the Scala standard library, which is presumed to be unlikely, and in fact it's very unlikely, right? Then both team B need to be recompiled and team A need to be recompiled, and therefore the whole project needs to be recompiled. Also, once we change the protocol, right? So let's say a team doesn't need a string to string, it actually needs a string to int somehow, right? And then the same thing is going to happen, right? B needs to change, right? So all of a sudden it needs to produce, I don't know, for example, the length of the message, right? So it will do message length, for example, right? And everything needs to recompile. So the whole thing is based on this assumption that you sort of can predict that the protocol is not going to change. All right, we're finally done with this video. Before I leave, I'm going to say a few more things, okay? So even though dependency inversion seems like a panacea, unfortunately, a lot of teams are struggling with slow compilation times, slow build times, crazy long estimations of their features because they don't have their dependencies under control, right? Because they don't have the flow of control under control, you know? Now, in my opinion, as a software engineer, not understanding the benefits of the inversion of control is it's one of the biggest flaws a software engineer can have. Again, a programmer shouldn't really care about this, but a software developer, software engineer, because a software engineer is usually dealing with crazy large code bases, he absolutely needs to be aware of the benefits of the inversion of control. Because if we're being honest with ourselves, we're sort of one-trick ponies, right? I'm exaggerating a little bit, but the inversion of control is basically literally like only one tool that we have, right? We even have jokes about this. We say that every problem can be fixed with just another level of indirection. We sort of use it as a joke, but sort of in the back of our heads we kind of know that there's some truth to it. Okay, so it is absolutely vital to understand this. This is why I over-engineered a teeny tiny function like this to show you how painful it can be. And one last thing, soon we're going to start talking about object-oriented programming on this channel, which uses precisely this technique. Object-oriented programming is a discipline imposed upon the inversion of control through subtype polymorphism. So you can just have pointers to functions flying around everywhere, like we're doing here, but you actually have different mechanisms over here, but over there. But the cool thing about Scala is that it blends object-oriented programming with the so-called functional programming in such a way that actually there are no pointers to function. So we actually over here, it's not visible, but what we're actually doing is really writing object-oriented code right now. Again, it's not really visible, but basically we're using subtype polymorphism as a higher order function. Okay, we're gonna talk about this more in depth in the future. It's just that I believe I claimed in the previous video or something that you absolutely need higher order functions to implement inversion of control. And maybe as someone who's familiar to object-oriented programming, you might have thought, well, hold on, we have this other thing. Well, this other thing is actually built on top of this, which is something that I'm going to explain actually very soon on this channel. All right, we're finally done, and I hope it wasn't too long, and also I hope that I didn't forget to mention one or two things. because this topic is actually it's one of my favorite topics, and again, I already mentioned this, one of the most important topics for a software engineer. So yeah, I hope you liked it. Like this video if you did, and subscribe if you're new here. There's going to be a lot of Scala content on this channel, and yeah, cheers, take care.